Okay, let's take a look at this problem here. It says the volume of a sample of gas at 50 degrees Celsius is 2.50 liters. Assume that the pressure is held constant. A. What is the volume of the gas at minus 10 degrees Celsius? B. At what temperature in degrees Celsius would the volume be 1.25 liters? C. At what temperature in degrees Celsius would the volume be at 2.75 liters? Okay, as I said before, when we're looking at volume, we know when we're looking at these problems, they're all somehow related to the ideal gas law. So PV is equal to nRT. In this particular instance, we're told that um, pressure is constant, and we know that R and T is constant. So if that's the case, we can group the constants together and we will get V over T is equal to some particular constant K. And we know that N and R is constant because this is a closed system and the volume doesn't change, or the number of moles doesn't change. Alright, so when we have this type of situation, we have V1 T1 is equal to V2 T2, and whenever we have this relationship, it is known as Charles's law. Alright, so as we read the equation, then again we label it. So a volume of a sample of a gas at 50 degrees Celsius. So that's the first temperature I come to. T1 is equal to 50 degrees Celsius. When you're dealing with Charles's law, you have to convert everything to Kelvin. So if I add 273, this would give me 323 Kelvin. I have a volume, 1 is equal to 2.50 liters. It says what is the volume, so my V2, which is in question, if I have a temperature that is minus 10 degrees Celsius. So I add 273 to this, and this would give me 273 Kelvin. I then take the data that I have and substitute it back into my equation. I'm looking for V2, so that means I have to multiply both sides by T2, which means I would have V1 times T2 divided by T1 would give me my V2. I substitute this information back into the equation. V1 is equal to 2.5, so that's 2.5 times, this is T2. T2 is 263, and T1 is 323. When we do the calculations, we would get 2.04 liters. So, does this make sense? If I have my volume is proportional to my temperature. So if my volume goes up, then my temperature goes up. If my temperature increases, my volume will increase. So what happened here? I went from 323 to 273 in temperature. So that means that my temperature decreased. So if my temperature decreased, that means that my volume should also decrease, which I have 2.5 liters volume, which then went to 2.04. So that's consistent in what we have. Okay, let's look at part B of this question. Part B of this question says that at what temperature in degrees Celsius would the volume be 1.25 liters? So again, my V1 is equal to 2.50 liters. My T1 is equal to 323 Kelvin. My V2 is equal to 1.25 liters, and my T2 is equal to question mark. So starting from my base equation, V1 over T1 is equal to V2 over T2. If I solve for T2, that means that I'm going to have T2 is going to be equal to V2 times T1 divided by V1. I substitute my values back into the equation. V2 is equal to 1.25 liters. T1 is equal to 323. And V1 is equal to 2.50. So when I do my calculation, I would get 161.5 Kelvin, but the question doesn't ask for you to have your answer in Kelvin. It asks for it in degrees Celsius. We know that Kelvin is equal to degrees Celsius plus 273. So if that's the case, I can know that my Kelvin is 161.5 is equal to degrees Celsius plus 273. I subtract 273 from both sides of the equation, and when I do that, okay, let me get some room over here. When I do that, I end up having I have Kelvin is equal to degrees Celsius plus 273, and I already know that my Kelvin is 161.5 Kelvin is equal to degrees Celsius plus 273. So 161.5 minus 273 equals my degrees Celsius, which is a negative 111.5 degrees Celsius. Okay, so that's how we would finish off that question. Let's take a look at part C. It says, at what temperature in degrees Celsius would the volume be at 2.75 liters? So again, we write down the values that we know. We have V1 is equal to 2.50 liters. We have T1 is equal to 323 Kelvin. We have V2 is equal to 2.75 liters. And we know that T2 is equal to our question mark. That's what we don't know. So if we set up our equation, V1 over T1 is equal to V2 over T2. Solving for T2, we would have T2 is equal to V2 times T1 divided by V1. Substitute our values back into the equation. We get 2.75 times 323 divided by our V1, which is 2.5. And when we solve this, we would have 355.3 Kelvin, and the answer is asked to be in degrees Celsius. So that the answer is in degrees Celsius, we just go say that Kelvin is equal to degrees Celsius plus 273. So degrees Celsius is equal to Kelvin minus 273. And we know that our Kelvin for this was 355.3 minus 273, which is going to give us 82.3 degrees Celsius. Okay, so these are typical examples of typical ways of how to solve um, Charles law equations.